Hey everyone, and welcome. Artificial intelligence really does feel like magic sometimes, doesn't it? I mean, it can see, it can listen, it can even create stuff. But what if I told you that behind all that modern day wizardry is something you probably ran into back in high school? All right, let's get into it and uncover the secret engine that's powering our entire AI driven world.
Seriously, it's almost creepy sometimes, right? How on earth does it sift through literally millions of movies and shows to find that one perfect recommendation just for you? Is it like reading your mind? Well, no, not exactly. It's doing something way more structured and honestly, a lot cooler. Get this. The secret hero behind the most advanced tech of our time is linear algebra. I'm not kidding. That stuff with the X's and Y's, vectors, matrices. Turns out it's the fundamental language for pretty much all modern artificial intelligence. So, to really understand what's going on with AI, we kind of have to learn the language it speaks. And it's all built on just a couple of main ideas from linear algebra. And don't worry, it's way more intuitive than you might be thinking. Okay, first up is something called a vector. Now, forget the textbook definition for a second. Just picture a vector as an AI's shopping list, but for one single thing. So for a movie, that list might have numbers for its genre, the year it came out, how long it is, and what you rated it. It's just how an AI grabs one thing from our world and turns it into a simple list of numbers it can work with. So, what if you have a list for every single movie on Netflix? Well, that's where the matrix comes in. A matrix is basically just a huge grid, kind of like a spreadsheet on steroids. It takes all of those individual shopping lists, all those vectors, and lines them up in neat rows and columns. And bam, just like that, you've organized the entire world of movies. This is how AI wrangles these massive, massive amounts of data all at once. All right, so AI has these super powered spreadsheets called matrices. But how does it actually use them to make sense of our complicated world? Let's take a look at a real world example. Now, check this out, because this is where it gets really powerful. Imagine all the data from a hospital. In this matrix, every single row could be a different patient. And then each column is a specific measurement: their age, their heart rate, their blood pressure, you name it. By organizing data like this, an AI can search for patterns across millions of patient records at the same time, something a human could never, ever do. And this idea doesn't just work for medical records. It applies to pretty much everything. The pixels that make up a photo, the sound waves in your voice, your entire Spotify listening history, all of it can get translated into these giant grids of numbers. This is fundamentally how an AI learns to see a face in a picture or hear a command you give it. At the end of the day, it's all just numbers in a grid. Okay, so we've got our data organized into these neat matrices. Now we need a brain to actually process it all. In the world of AI, that brain is called a neural network. And its entire thought process? It's pure math. Now, this formula might look a little scary, but the idea behind it is actually pretty simple. A neural network takes your data, that's the input matrix, and it multiplies it by another matrix full of numbers called weights. You can think of these weights as the network's memories or its past experiences. By doing this math, the network is basically weighing the evidence. It's deciding how important each piece of information is for making a final decision. The whole thinking process is just a huge chain of these calculations happening at lightning speed. And that's the million-dollar question, isn't it? I mean, it's one thing to just multiply a bunch of numbers together, but how does the network figure out which weights are going to lead it to the correct answer? It can't just be guessing, right? It learns through trial and error, but on an absolutely insane scale. The process is called optimization. So first, the network makes a prediction. Then it checks to see how wrong that prediction was. That's the error. Based on how wrong it was, it goes back and just slightly adjusts all those numbers in its weight matrix to do a little bit better next time. Now here's the crazy part. It does this over and over and over, millions, sometimes even billions of times. And with every single cycle, it gets a tiny bit smarter, slowly tweaking those numbers until its predictions become unbelievably accurate. So we've gone from these simple lists of numbers to these enormous self-correcting computational brains. Let's tie this all back to the real world and see where this mathematical engine is actually running all around us. And boom, suddenly you see it's absolutely everywhere. The phone that unlocks when it sees your face? That's matrices doing their thing. A self-driving car navigating a street? You guessed it, linear algebra. That Spotify playlist that just gets you? The goofy Instagram filter that puts cat ears on your head? Even the chatbot you talk to for customer service? Every single one of these technologies is running on the exact mathematical principles we just walked through. So at the end of the day, what feels like pure magic is really just math. Incredibly complex and super fast math, for sure, but still just math. All of these incredible technologies depend completely on linear algebra to even exist. It's like the invisible architecture holding up our modern world. So we've basically given machines a language to understand our world through data. We've taught them to see, to hear, and to recommend stuff to us. So now that you know the secret, the real question is, what's next? What else can we, and what else should we, teach machines to do? Thanks so much for joining me.